Oke, Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back again with me. My name is Tony Farhan. My number is 12 10 17 10 58. Today I'm gonna do some presentation, talk about my reference paper. The title is Selective Mapping Technique for PAPR Reduction in OFDM System. Okay, let's begin. What will be discussed in this presentation first is orthogonal frequency division multiplexing or OFDM, and then second one is peak to average power ratio or PAPR, and then the last one is selective mapping technique for PAPR reduction, which is the method that I choose to decrease the PAPR in OFDM system. Okay, start. Orthogonal frequency division multiplexing or OFDM is a technique that divides a high rate data stream into n low rate streams and converts these data streams into time domain signals for transmission using inverse Fourier transform, or maybe we call it as IFFT. OFDM is a form of multi-carrier modulation technique with high spectral efficiency and immunity to interference. One major drawback of OFDM systems is the high peak to average power ratio or PAPR, which leads to power inefficiency and signal distortion with practical power amplifiers used at the transmitter. This is the signal of OFDM. From this image, we can see that if one signal reaches the highest peak, so the other signal will be zero. This is the peak, and then the other will be zero. Uh, this is the peak, and then the other signal will be zero. This is why this is called orthogonal. Okay, next slide. This is the system model of OFDM. This is the FFT, the point of OFDM. This is transform the signal from frequency domain to time domain. Okay, next. Now peak to average power ratio or PAPR. In the OFDM, the RF power amplifier cannot operate efficiently due to high PAPR. This amplifier must be used in its linear region to combat distortion, out-of-band noise, and PER degradation. Low PAPR makes the power amplifier operate efficiently and also reduces the complexity of the DAC and ADC. Yeah, this is the equation of PAPR. Yeah. This is the linear region where the RF amplifier work efficiently, and this is saturation region where will be noise. That's why we have to decrease the PAPR, so the signal will be on this region. Nah, will be noise or degradation. That's why we need to decrease the PAPR. Okay. Now the method I choose or the technique I choose is selective mapping or SLM. The basic idea of SLM is to produce U alternative transmit sequence from the same data source and then to select the transmit signal exhibiting the lowest PAPR. This PAPR SLM reduction is obtained by multiplying a series of factors phase with a row of information data, then the PAPR value of each phase factor product is calculated with a row of information data. This is the block, this is the U. So the data source is transformed from serial to parallel. Yes, this is X1, X2, and XU. from this the information is the same, but the P1, P2, and the PU is randomly. So from that, this is EFFT, and then from there select the one with minimum PAPR from the multiplying P, and then the data information. Okay, then this is the result. The result is N is subcarrier on the OFDM system, and then U is the subblock. So more N will be more will increase the PAPR, and then more U will decrease the PAPR. So we have to choose the right threshold, so the PAPR will be efficient for the power amplifier.